Today we're going to discuss solving systems of linear equations, and there's three scenarios with two straight lines. You could either have the two lines overlap, as in this situation, they could intersect, as in this situation, or they could never intersect at all, which is occurring when the lines are parallel. So this is the most common one, where you have two separate lines that intersect in one spot, and it has one solution. It's called consistent and independent. This is where you have two parallel lines. They have the same slope but different y-intercepts, and there are no solutions because there are no intersection points. It's called inconsistent. And then this is where you have two lines. There's a purple line and a green line on top of each other, and we have all solutions that occur on that line. So there are infinitely many solutions, and that's consistent and dependent. We're going to be solving each equation for y equals so that you get it in the form y equals mx plus b. So you can graph just as you normally would. The only difference is you'll have two lines instead of one line to graph. You're going to graph each line, and then you're going to find the intersection, and you're going to list your solution either as a point if you have just one ordered pair, as in this case, or if you have no solutions, you can say empty set. And if you have infinitely many solutions, you can say that you have infinitely many solutions. All right, so for the first problem, it says determine if the ordered pair is a solution to the system. Solution means it has to work in both equations. So this ordered pair, 4, 2, my x is 4, my y is 2. I'm going to substitute it into each equation. So I have x minus 2y equals 0. And so 4 minus 2 times 2 equals 0. And then just do your order of operations. So 4 minus 4, that equals 0. And that is true.
Learn Wozniak, please dial extension 5322.
Then I have to test it in the second equation. So 4 plus 2 equals 6. 4 plus 2 really does equal 6. And so this is true as well. So since it's true and it's a solution to both equations, then it's a solution to the entire system. So the answer is yes. All right, for the second problem, I've got 0, 3. 0 is my x, and 3 is my y. So I'm looking at the first equation, 3x plus 4y equals 12. 3 times 0 plus 4 times 3. And I'm going to do 3 times 0 is 0 plus 12. 0 plus 12 does equal 12. So that is a true statement. So it is a solution to that equation. Now I'm going to check to see does it work in the second equation. So I've got 5 times 3 minus 2 times 0. Notice your y is here and your x is here. And we're going to see if it equals negative 6. So we have 15 minus 0. That's 15. Well, that obviously does not equal negative 6. So this is not a solution of the second equation. Since it doesn't work in one of them, it is not a solution, or it's not the solution to the system. All right, flip over to the other side. So now we're going to graph using these steps. Okay, so the first problem, we have to solve for y equals. The second equation already is in y equals form, so we're okay. But in this one, we have x plus y equals 6. So I'm going to subtract x from each side. So I've got y equals negative x plus 6. All right, so I'll graph the first equation. We have y equals negative x plus 6. So I'm going to start at my y-intercept of plus 6. My slope is down 1 over 1. And I'm going to make as many points as I can just because I don't know exactly where the other line is going to end up. So I'm going to go up and to the left, up 1 over 1 as well. And do your best to draw an accurate graph. So if you have a ruler or your ID, you can use that as a straight edge. All right, I'm going to do the other line in a different color. So the other line was y equals x plus 4. That's already in y equals mx plus b. So I will start with my y-intercept at 4, and I'm going to go up 1 over 1. And I can already see where this intersects, so I don't have to draw as many points for this second line. All right, so now I'm going to look at where is my intersection. There's one solution. So this is your consistent and independent situation, and I need to list my answer as where the ordered pair is. So it's at 1, 1, 2, 3, 4, 5. If you want to, you can go back and check to make sure that this really does work. So that's my solution. I can check by taking my x and y and substituting it into my x plus y, so 1 plus 5, and see if that really does equal 6. So that works, and I could plug it into 5 equals 1 plus 4, and 5 does equal 5, so since it is a solution to both equations, then that really is the solution to my system. Alright, I'm going to do the same thing with problem 4. So problem 4, first I'm going to solve the top equation for y. I'm going to subtract 2x. I have 3y equals negative 2x plus 12, and I'm going to divide everything by 3. So I have y equals negative 2/3 x plus 4. I'm going to graph that by starting at the y-intercept on the y-axis, and I'm going to go down 2 over 3. And I'm going to make as many points as I can, so I'm going to go up 2 and over 3 to the left. And then I'm going to use my ruler. So that's my first equation. My second equation is over here, so I'm going to subtract 2x on each side. And I have negative y equals negative 2x plus 4. And I'm going to divide everything by negative 1. And I have y equals positive 2x minus 4. So this time I'm going to start at negative 4. And I'm going to go up 2 over 1 until I get to an intersection point. And I'm going to draw on the line, and so I could find my solution. It's at 3, 2. So the final answer is 3, 2. But I'm just going to check just to make sure that I did find the correct solution. So I have 2 times 3 plus 3 times 2, and that should equal 12. So I have 6 plus 6, and that does equal 12. So I know for sure it's on the black line. And then on my second equation, I have 2 times 3 minus 2, and that should equal 4. So 6 minus 2 really does equal 4, so that's on the green line. And since it's a solution to each equation individually, it's a solution for the entire system as a whole.